Hey, what's happening, guys? Today we are going to talk about resistors and LEDs for the complete beginner. And we're going to talk about using your LEDs both in series and in parallel, because we're going to pick up some more Arduino projects here in the near future. And I want you guys to be down with using the LEDs and everything you need to know about them. So if you're a seasoned pro, you might want to skip this. If not, dig in, because I think you're going to find some really cool and useful information here. Now, on a side note, before we get started, for you guys out there that are hams, I have just gotten into DMR. This is my new DMR handheld, the TYT MD380, which is one of the most popular ones out there. Low cost, works really great. Anyway, the reason I want to tell you guys this, if you're hams, is because I'd like to talk to you. So I hang out a lot on TAC 310. So give me a call if you're on there, WW8PR, and I'll answer you, and we can chat. All right, now let's get on with talking about LEDs and the resistors you need to drive them. Like I said, this is going to be for the complete beginner. So your LED is a light emitting diode. The symbol for it is just like a diode, but with a couple of beams of light coming off of it. And that means it has an anode, the plus end, and a cathode, the minus or the negative end. And as long as current runs from the anode to the cathode and you have enough voltage, the LED will light. If you run it backwards, at a low voltage, nothing's going to happen. At a high voltage, you'll probably blow it up. Now, the thing about the LEDs you have to remember is they are current reactive. That means the more current you give them, the brighter they will get. So you have to use an LED, you have to use a resistor with your LEDs, otherwise they'll burn out. Now, so you want to know, how do you pick the right resistor? That's always the number one question, the big thing. Well, to pick the right resistor is basically an exercise in Ohm's law. So we need to know three things. We need to know the voltage that you'll be giving them, and we need to know the current at which you want to run them. Now, you can go into your LED data sheet and it'll give you the information you need. But basically, the maximum current you want to give an LED is 30 milliamps. That's a maximum, absolute maximum. A good average current is, let's say, 15 milliamp. If you run them at 15 milliamp, you're not going to overstress them, and they're going to have a good long life. So we can figure out what resistor we need to know by using a really simple formula. Our resistor is going to equal little math here. Our source voltage minus the voltage drop of the LED over the current at which you want to run the LED. So just to make this simple, if we say we're going to run this at 5 volts, which is our standard Arduino thing, and our LED takes 2 volts, that's going to give us 3 volts that we need to drop over our suggested current of 15 milliamps, or 0.0015, or the I'm sorry, 0.015. All right, yeah, 0.015. And that will give you the resistor you need. Now, unless you've got every resistor known to man, you're probably not going to have the exact value. Round up to the closest value you have, and you'll be fine. So like I said, you can use the data sheets to figure out the exact voltage that the LED needs to light, or you can just have a little fun and play around with it and do it yourself. So that's what we're going to do here. I got some different LEDs here. In this tray we've got a purple, an orange, a green. I'm sorry, that's a red. And these ones are orange. Now they'll all light at relatively a very close voltage. So let's say we have green, red, purple, and orange. Okay, so I've got my power supply here. Right now it's set at 1.5 volts, but we're going to vary that. And I've got it set for a maximum of 15 milliamps. So what we can do here is I've got this multimeter slaved to that, so we don't have to keep moving the camera around, because that can be a pain in the butt. So there's our actual voltage, 1.602. And we're going to start out with a red LED. Now, for this, we don't need a resistor on it because I'm using the power supply itself as a resistor. Now, you notice the LED has two legs, the anode and the cathode. The anode is always longer than the cathode. Alright, so we'll clip our ground on first. And then the positive, the anode, cathode, anode. Now that's already lit. I know it looks white to you, but it's red. So I'm going to just drop this voltage here a little bit. Okay, so it is not lit now. Let's find out where it actually comes on. Right there. So 1.6 volts, we'll say, for our red LED. 1.6. Then we'll move on and we'll do our purple. Okay, we got nothing at 1.6. We'll take it up a little bit. Okay, it is lighting at 2.4. So you can see how they all take a different drive voltage to light them up. Next up, we have our green. I'm going to drop our voltage back down here. Light up the green here. Find out where it comes on. Green's also coming in at 2.4. And finally, one of these orange LEDs. Man, they're really in there. One second. Oh, some serious tape on the orange one there. I had to get a knife on it. Okay, so orange, where's orange going to light up? Orange is lighting up at 1.7. Just a little bit more than the red. So now we have a basic idea here in this table of the voltages required to light our LEDs. So let's just stick with, say, the green one since it's first on our list for today. Alright, so let's clamp her in here. And hopefully you'll be able to see here the different varying levels of light with the current. We're not going to change the voltage. Alright, so we set our green lights at 2.4. So we'll see if we can adjust here to a nice 2.4. Alright. There. Green's lit up nicely at 2.4. Now, what I want to do here is bring in one more meter set up as an ammeter. so that you guys can follow the current that it's going to take. So I'll just clip the positive lead to the positive there. And then when I touch the negative lead to the cathode here, you can see it lights up, and we're down there. Oh, that's microamps. Let me get a different set of leads. Hold on. Go with these alligator clip leads to make everything a little easier on us. Alright, so there we go, clamp our ground on. There we have our green LED lit. We're at like 0.2 milliamps. So if we raise it up, why is this thing not reading? One moment. Switch them around so it's working better now. Now I put the voltage up to 5 volts so we have some wiggle room with our current. So right now you can see we are at 0 milliamps. When we start putting some current into here, you can see the voltage begins to rise, but we haven't reached that magical point yet. There we go. Now that's at 100 milliamps. Your LED is not going to last very long at 100 milliamps. So we'll bring her down here to a nice reasonable level. This power supply is super touchy. Let me see if I can adjust this better. Alright, so there's 45. That's about as low as I can get this power supply to go reasonably. But I want you to watch what happens as I increase the amperage, the current. 200. Oh, boom. We killed it. So that's what happens when you add too much current. So what we need to do is we need to settle on a good voltage for our LEDs, and we're going to go with 5 volts because that's what your Arduino puts out. So we'll set our power supply for 5 volts, or as close as we can get this touchy thing. Nothing's ever exact when it comes to this. Now we'll swing over here to the power supply one more time, and you can see the amperage, the current is cranked all the way up, so it is not limited in any way. And we can get these meters out of here and we'll set something up. So we'll bring in a breadboard and some 330 ohm resistors, which work really nice for 5 volt current limiting for LEDs. And we will go from the power, from the positive, our source voltage, to the anode of the LED. Now let's try it. Let's make it easier on ourselves so we don't have to use a bunch of jumper wires here. We'll stretch this out a little bit here. There we go. So from VCC to the anode of the LED, and from that to our ground. Now I'm just going to put in some of these header pins so I have somewhere to connect our power. And when we connect everything, connecting the grounds first, this should light up. Ta-da! You can see we're putting in 5 volts. But where is our current? So we have to read current in series. And that's what we're going to do here by simply pulling out the cathode and we'll put our meter in series. No. And we're at 6 milliamps. So you can see we're nice and bright. 6 milliamps, your LED is going to last a long time. Now, let's put it back like we had it. What did I do wrong? There we go. Now, the easiest way to add more LEDs is in parallel. So we can add another resistor and another LED. You can see our voltage remains the same. Let's do it again. We'll set up an array. All of these in parallel. And I will draw this circuit for you here in a second so you can understand what it looks like when you see it on a circuit diagram. Let's do two more. One moment. All right, we're hooking up the last one here. So now we have an array of 5 LEDs in parallel. And you can see, pardon the glare there from my bench, we're still at our 5 volts. And you would also see that because they're in parallel, if we measured each one individually, the current, that they are all getting the same current. Now, I can do that here really simply by measuring the total current going to the board itself. This is called Kirchhoff's current law. I'm not going to get into that today. So, all of those, we have 5 divided by 6 is, or 5, each one getting 6 milliamps, so 5 times 6 is 30. And there you can see we've got 29.48 milliamps. That would be the most you would want to drive off of one Arduino pin. Now, if you wanted to drive more, you could simply increase the number of resistors, but 5 is pretty good. I'm not increase the number of resistors, increase the value of the resistors. So there you have your LEDs in parallel. Now, what about if you wanted to do it in series? We can hook this up in series as well. Let me remove all this from the board and I'll come back and we'll do that. Okay. So here they all are hooked up in series. We have one resistor, the same 330 ohm resistor, going to the cathode of LED number 1. And then the anode of LED number 1 goes to the cathode of number 2, and so on to 3 and 4 and 5. Same voltage. But we have no current and we have no LEDs lit. Whoops. Yeah. And the reason for that, Paul, is because you didn't plug them in. Okay, there we go. So everything's plugged in, but we've got nothing. And why is that? Well, that's because the difference in series and parallel is in parallel, the same voltage is shared through all the LEDs, but the current is additive. Now, in this case, the current is shared through all the LEDs, but the voltage is additive. So we're going to need to increase the voltage here to get these LEDs to light. So keep your eye on that voltmeter as I increase the voltage. Where do you think that they're going to light? All right, we're very dimly lit at 13 volts. And we have 0.22 milliamps. So if we want to get them back up there to our 6 milliamp, Well, there we are at 8. Let's get it back to 6 where we wanted it, because that's where we were before. So you see, we had to take it all the way up to 17.4 volts. So where's our math involved in this? Well, if you remember from our table, those greens lit at 2.4 volts. 2.4 times 5 is 12. So they should light at about 12. If we take it down to 12, we'll probably get something very, very dim. Yeah, can you see that? They're lit, but there's not much going on there. That was our basic lighting point. So to get them up to the equivalent of where we were at about 6 milliamps, we have to take them up to 17.26 volts. Now, can you do that from an Arduino? Not by itself. You're going to have to use a transistor, and that's not something we're going to get into today. We're just going to stick with this. If you want to use multiple LEDs from one pin of an Arduino, then you're going to have to run them in parallel to keep the current low. If you tried to do it in series to get the same equivalent, you see the voltage has to be way up to get the same equivalent current. Now, just as a simple demonstration, I'll pull out the green LEDs. Oh, and there's something else. As soon as I pulled out one LED, we broke the circuit, so all the LEDs went out. If we did it in parallel, that wouldn't happen. So let's do the same thing with red LEDs, which, if you remember from our chart, light at 1.6 volts. We'll do the same. I think I have 5 red LEDs here. There's one. There's 2. There's 3. 4. And 5. So now at the same voltage, hey, how'd you get in there? You weren't supposed to be there. Somebody has misfiled my LEDs. Where'd the rest of them go? Alright, well, we'll have to throw in an orange, which is relatively close, right? Right, no big deal. How do we do that? What did I mess up? 1, 2. Is it that one? One moment. So you can see we're at 19 milliamps with the same voltage. And again, if I pull one, they all go out. Let me redo this as parallel real quick. Okay, so there we are, back to our parallel setup. And you can see I can remove any number of them. It doesn't pull out this string. The current goes down. The voltage stays the same. Alright. Hopefully you got something out of that. I didn't confuse you too much. I want to thank you guys for watching. If you enjoyed this, give me a thumbs up. Feel free to comment and share. Don't forget to subscribe. Big thanks to all my patrons. If you're not a patron yet, please consider joining. $1 a month helps us get stuff, make new videos, and you get some neat benefits. Check out the Patreon page to find out more. There's a link to it down below. That's it. I am out. Peace.